Hello all, welcome to my course on methods of adhesion measurement, theory and practice. We are discussing about contact mechanics and today we are on our 10th lecture. So, we are discussing distributed normal and shear load on an elastic half space, and we are also estimating surface deformation and deformation gradient of this elastic half space. In the last lecture, we discussed about this linearly varying normal load on an elastic half space, where this pressure P x varies as P 0 by A into A minus mod x, and the shear load is equal to 0. And we estimated that at a point x z, the normal component of the stress x x can be written as something like this, where theta 1 is this angle defined over here, theta 2 is the angle x z, and theta z is this angle x theta 0 over here, from this point, middle point to this particular point. Remember, this is a symmetric distribution from minus a to a, and so we want to find today the other components of the loads like the zz and also the deformation profile of the surface because of this distribution, load distribution. So, here before that we will consider a special case, for example, that if x x is given like this, then what is the stress that x x will be on this particular z axis, let us say. So, z axis can be defined as x is equal to 0. So, when x is equal to 0 z axis, this theta 2 will be equal to theta 2 over here. So, this is also theta 2 here. So, theta 2 is equal to pi minus theta 1. So, if I substitute this theta 2 is equal to pi minus theta 1 in this equation, then what do I get is something like this. So, x x is equal to minus 2 z p 0 by pi into a, and here minus a plus x by 2 z, and here theta 2 is pi minus theta 1. So, it is pi minus theta 1 minus theta 0 here minus half, and here it is sine 2 theta 0 minus sine 2, and instead of theta 2 I have pi minus theta 1 here. This bracket gets closed, plus ln of over here sine of theta 1 into sine of, this is pi minus theta 1 by sine theta 0 square, and then I have minus, I have a minus x by 2 0 here, and here it is theta 0 minus theta 1 minus half of sine minus half of sine of 2 theta 1, this is sine of 2 theta 1 minus sine of 2 theta 0, bracket close, and then plus half of here 2 sine square theta 0 minus sine square theta 1 minus sine square, this is theta 2 is pi minus theta 1. So, remember that pi minus theta 1 will be equal to sine theta 1, and sine 2 pi minus theta 1 will be minus sine 2 theta 1, like that. So, we can substitute, we can work out that, and therefore, we can write here. So, here we can write then is equal to minus 2 z over pi, and over here this is into 2 z by pi into p 0 by a over here, and then here it is minus, and it is at x is equal to 0, and so therefore, here it is minus a by 2 z, and it is pi minus theta 1 minus theta 0 minus, this is half of sine 2 theta 0 minus, so this is 2 pi sin 2 pi minus x is minus sin x. So, it should be sin 2 theta 0 and plus sin 2 theta 1 bracket is closed over here and plus ln of this is sin theta 1 and pi, sin pi minus theta 1 is sin theta 1. So, it is sin square theta 1 divided by sin square theta 0 over here minus a by 2 z, and this is theta 0 minus theta 1 minus half of, and then here sin 2 theta 1 minus sin 2 theta 0 like this, and then plus half of here this quantity whatever is there. So, this is 2 sin square theta 0 minus sin square theta 1 minus this sin pi minus theta 1 is minus sin x, so sin theta 1, so it should be minus sin square theta 1. So, like that. So, we can now further simplify it, and we can then think that okay, let us say that so we can further simplify it and we can work it out. So, a little more algebra, but let us say that we want to figure out that what will be the stress, let us say at this particular point. So, this is at z is equal to 0. So, at z is equal to 0, at here z is equal to 0, this theta 2 will be equal to 0, theta 2 will be equal to 0 here, and theta 1 is actually equal to pi here, and theta 0. Okay. So, theta 0 as I said that this is be already pi by 2, theta 0 should be pi by 2, because this point has here from here it has come to theta 0 as this angle. So, theta 0 is basically this angle over here. So, that is pi by 2. So, we can substitute all that over here where z is equal to 0 and theta 1 is equal to pi, and you will see that this 2z by pi. So, 2z by a we can multiply it over here and we can further simplify it. I am not going all that, and finally, we will get that x is equal to minus pi p 0. So, at x is equal to 0, at x is equal to 0, the stress, the normal stress okay, along the x direction, that is equal to the compressive load, and so there is this is compressive. So, the stress is negative over here. So, therefore, it is minus of p 0. Now, let us estimate zz. So, the zz is given by this expression in which minus this expression where this Ps can be defined as minus a to a, and the Ps is written as p 0 by a and a minus mod of x divided by this quantity which is whole square over here. So, over here like that. So, we can now integrate that. So, we need to integrate. So, let us say this I is equal to minus a to a, and let us say that we take only these terms a minus. So, now a to a. So, we will define these limits from a to 0 and 0 to a. So, let us say minus a to 0 here, and this is a to 0 here. So, here let us say this term is a minus of x. So, it is plus x divided by a, and this is x minus s whole square plus z square, and this is whole square, and then plus it is 0 to a is the other limit. In this limit it is a plus x by a, and this is whole square. So, like that. So, this is a plus x and this is a sorry it is a minus x, like that, a minus x, it should minus x because between 0 to a this mod of x should be written as x. So, therefore, it is a minus x like that. So, we need to now integrate this part, and that we can do here. So, for example, here this is let us say now it is in terms of s here. So, therefore, it has to be written actually in terms of s, this is not x here, this should be in terms of s. So, this is because we are integrating with respect to s. So, it is a ds over here also I should write ds over here, and here it is s, here it is also s, otherwise there will be mistake. So, ds s over here. Okay, okay, fine. So now it is S here. So here it is like that. So now we need to integrate this, and I will do something that is very similar to what we had done it in the last lecture. So here it is a plus x, we can write it like that, minus, let us say x minus s, and this is ds, and this is x minus s square plus z square here. So it can be written like that, and so therefore I can write it as two different integral, a plus x, this is x minus s square plus z square whole square, this is d of s, and minus of this is d of s, and into it is x minus s, and then here square. So we can write x minus s is equal to z tan theta, and so therefore this will give minus ds is equal to z sec square theta d theta, sec square theta d theta. So let us substitute over here. So then I1 here, that is equal to, it will be, let us say it is a plus x, and here it is x minus s. So ds, so ds is equal to minus of minus over here. So let us say minus is here, z here, sec square theta d theta, and x minus x is square. So it is z square. So z square, it is z to the power 4 here, z to the power 4 here, and this is x minus s is z. So tan square, 1 plus tan square theta sec square theta. So it is sec 4 theta here. So it is sec 4 theta here, yeah, sec 4 theta here. So like that, and the next, the other term minus here, and then it is, let us say ds is minus this, so it should be plus here, and this is x minus s. So x minus s also I can substitute here z tan theta. So it is z tan theta here, and it is z sec square theta d theta here. X minus s is z tan theta, and ds is here. So ds is minus z sec square theta. So minus minus plus over here, and this is z sec square theta, and over here it will be here, this is again z 4 theta sec theta, z 4 sec theta, sec 4 theta, sec to the power 4 theta, same as the denominator over here. So this is the way. So now I can write it minus, and this is z here. So it is z cube minus 1 by this is z cube into a plus x, and then it is sec square theta and sec 4 theta. So this will be 1 by sec square theta, 1 by sec square theta is cos square theta, and 1 by cos square theta. So cos square theta, so I divided by 2 here, this is 2 cos square theta, 2 cos square theta is 1 plus cos 2 theta, 1 plus cos 2 theta d theta, okay, and then plus this is 1 by z square here, and here it is sec square theta in the denominator, this is sin theta by cos theta, and this is sec square theta. So 1 sec theta gets cancelled, so it will be sin theta cos theta, and I will divide it by 2 to make it sin 2 theta. So sin 2 theta, that is what I should get, and d theta like this. So again here tan theta sec square theta sec square theta sec square theta sec square theta, this is tan theta sin theta by cos theta. So therefore it will be sin theta into cos theta divided by 2 here. So it is 2 sin theta cos theta is sin 2 theta. So like that, and so here I have already done all this, and finally I will get here sin 2 theta over 1 plus cos 2 theta and sin 2 theta, and now you integrate it. So it will be theta plus half of sin 2 theta, and then minus, because sin 2 theta minus cos 2 theta, so it is minus half of 2z square into 2 cos 2 theta like that. So we know the integration limit, so between minus a to 0, and in the last lecture I had shown that for s is equal to 0, this theta here, okay, should be pi by 2 is equal to 0. So s is equal to minus a, let us say first. So s is equal to minus a, So, theta is equal to pi by 2 minus theta 2. So, please see my last lecture in which I had described this part, and at s is equal to 0, this theta is equal to pi by 2 minus theta 0. So, this is the limit that has been used over here, and we also use these results, these are known results, and if we do that, then we will get here is equal to minus of, this is a plus x by 2 z cube, and here it will be pi by 2 minus theta 0 minus pi by 2 minus theta 2, so it will be theta 2 minus theta 0 and plus half of, this is sine, and sine pi by 2, so it is pi, so it is pi minus 2 theta 0 minus sine, this is pi minus 2 theta 2. Yeah, and so this is this part, and then minus, it will be 1 by 4 z square, and this is cos of here bracket. So, it will be pi minus 2 theta 0 minus cos of pi minus 2 theta 2. So, now we use these results again, and we can write pi minus sine pi minus 2 theta 0 is equal to minus sine 2 theta 0, and here it is pi minus 2 theta 0 is sine 2 theta 0, and pi minus 2 theta 2 is sine, and cos pi minus 2 is minus cos, and here is minus cos. So, like that. So, we can simplify this expression here, and it will be minus of a plus x by 2 z cube, and it will be theta 2 minus theta 0 plus half of, this is pi minus 2 theta 2 0. So, it is sine 2 theta 0 and minus sine 2 theta 2 over here, and minus 1 by 4 z square, and one can take this part also. And so, finally, after doing all this, one will get this expression. The other part will be a minus x, but remember that there are two parts there. So, we have to integrate the other part also. So, over here we have just integrated this part, and I have left with this part. So, this part is over here. So, this is a minus x, x minus is z square, etc. So, this part, so we can write this part, and so here this integration between 0 to theta 2, right, 0 to theta 1, right. So, here it is like this. Here again we use this substitution, and then we can simplify this here a minus x over here. So, we can write this expression a minus x s is equal to a minus x plus x minus s, and this x minus s comes over here, and so we can substitute over here this the same way that we did in the last time, and we can get here something like this, and this boils down to this a minus x by z cube here, and this part I had already written here cos square theta in the last derivation only, and then over here sin theta cos theta I have already run it, and so therefore it comes out to be like this. So, finally, this expression will come out to be minus here it is a minus x by 2 z cube and theta plus half of sin 2 theta plus 1 by 4 z square cos 2 theta. So, remember this whole thing, the limits. So, as I said that when x is equal to 0, this theta will be pi by 2 minus theta 0, and that a will be pi by 2 minus theta 1. So, it is pi by 2 minus theta 1, that is the way it will be, right. So, we have already done this particular thing in the last lecture. So, if I substitute all that for the theta these quantities, okay, so then I will get this expression very nicely. Over here this is theta is replaced by at theta. So, from here I get theta 0 minus theta 1, because this is pi by 2 here pi by 2 minus theta 1, pi by 2 minus theta 0 here. So, therefore, we will get like this, and here I will get like that because it is sin 2 theta here. So, sin pi minus sin 2 theta 1 is sin 2 theta 1, and like that. So, therefore, I will get here, and here again I will get something like this, because cos pi minus x is equal to minus cos x here. So, therefore, I will get here plus 1 by 4 z square, and from here I will get this term like this. So, here now we have to add up for both the limits. So, for example, here I had remembered that I had integrated it between minus a to 0 some term and then plus some term over here, and then I had integrated from some term here from 0 to a, and so I would like to add both these terms. So, that is what we have done here, and once we do all that and we do little more algebra here, we will get this particular expression. This particular expression we will get by adding up the terms. So, it comes out like that. Now, we can further simplify it by taking this minus 2 z cube by a inside, okay, and we can do that, and we will get here like this minus 2 z cube by a. Once you take it inside, so it will be a plus x by a and theta 2 minus theta 0 plus these terms, and here it will be minus 2 z cube by a. If I multiply, so it will be z cube, so it is z square here, so it gets z only, and this is 4 here, it is 2 here, like that. So, and this a comes over here. So, here and outside the bracket I have pi 0 by p 0 by pi, and the rest is inside, where this is the z dependent term and is the x dependent term over here. So, finally, I will get here like that. Now, let us say that I want to again find out that what will be the displacement, what will be the stress along the z axis. So, at which x is equal to 0 and pi by theta 2 is equal to pi minus theta 1 and theta 0 is equal to pi by 2. So, here in this case, as I described here, for example, I wanted to show that what will be the displacement at a point stress, normal stress z z at this particular point here, at which theta 2 will be equal to pi by 2 minus theta 1 and theta 0, which was defined over here theta 0. So, theta 0 here it will be pi by 2, like that. So, in order to take care of that, let us say that we substitute these expressions, these quantities, and so instead of theta 2 we will write here pi minus theta 1, and here theta 2 we will write here pi minus theta 1 here, and theta 2 again pi minus theta 1 here, like this. So, this is the way we have done, and we can use, so it will be pi minus 2 theta 1 here and 2 sin 2 pi minus theta minus sin theta 2 theta. So, sin 2 pi minus x is minus sin x. So, therefore, it is minus sin 2 theta 1 minus minus plus here, and here it is cos 2 theta like that. So, 1 by 0. So, here again it will be minus minus plus here, and line theta 0 is pi by 2. So, theta 0, so cos pi is minus 1. So, this minus 1 comes over here, this minus 1 comes over here, and minus here it comes out to be minus 2 cos theta 2 1 here. So, this is fine, all this one. So, finally, we will have this particular expression. Again, if I want to find out that what will be the stress at z is equal to 0, again at theta, so at that point theta 1 is equal to pi, as I did it for x x, and then z z 1 z z comes out to be equal to, if I substitute all that, so 2 pi cos 2 pi will be minus, so it is that z is equal to 0 and theta is equal to theta 1 is equal to pi. So, remember this z is 10 to 0 means z will multiply it over here, that needs to be multiplied. So, we do all that, and then finally, we will get this this expression where z0 will come out to be minus pi by 0 minus p 0. So, here again we see that the normal stress just below at x is equal to 0 and z is equal to 0 comes out to be minus p 0. So, that is the compressive load applied. So, it is a compressive stress that is developed like that. So, let us say that we want to figure out that if this is the elastic half space, this is the z axis, this is the x axis, and let us say that this is the way that the stresses are applied, pressure is applied, compressive load is applied. So, then what is the distribution of stresses at z is equal to 0 at this level. So, at z is equal to 0, theta 2, remember theta 2 will be equal to 0 and theta 1 will be equal to pi. So, we want to find out that. So, if we do that, we substitute for theta 2 is equal to 0 here and theta 1 is equal to pi here, okay. Then we will get it in terms of theta 0 here, something like this. So, here so we will get, so I think theta 2 also has to be theta 2 also has to be equal to 0 here. So, it is 0, theta 1 is equal to pi. So, that is also 0 here, and only here so half sin square theta 0 that remains. So, if you do all that, then we get finally this particular expression. So, here x x given as this. So, remember that if for these points okay, theta 0 will be equal to 0 for these points, because theta 0 was this particular angle. So, for these points theta 0 is equal to 0, x greater than 0, and for x less than 0 theta 0 is pi. For x at these points theta 0 is equal to pi. So, therefore, x x will be equal to minus pi p 0 1 minus x a, finally you will get, and x x for x less than 0 again we will get like this. So, what it means is that the normal stress x x okay, at the surface is same as, because it is compressive, is a negative compressive stress okay, as the force that distributes, that the load distributed the same way linearly okay, on the surface. And if we think about the normal stress z z, again the same way at z is equal to 0. Here we want to find out that what will be the z z quantity, that is the z direction normal stress, and that also if we work out the whole thing okay, same thing, as x greater than, at x greater than 0 theta 0 is equal to 0, at less than 0 theta 0 is equal to pi, and you substitute for theta 2 is equal to 0 and theta 1 is equal to pi. So, in essence you are finding out that there are all these points at the surface okay, how the stress values that changes. So, in all these cases again you will get the same expression for the z z and the at x less than 0 and at greater than 0, yeah, I should at greater than 0 here. So, the normal component stresses at the surface are equal and compressive for, so in fact it will be found for any distribution okay, that is what we will get. We will now go to we can say that x x x z, that the shear stress can also be found out. So, please try that as an assignment okay, I am not deriving it over here. Now, let us find out the deformations because of this particular stress distribution on the surface. So, for example, the distribution, the deformation that is vertical deformation v and horizontal deformation u, that can be found out from this equation over here. So, over here if I write it, it will be something like this. So, del v by at z is equal to 0 by del x okay. So, that will be equal to minus of 2 into 1 minus sigma square by pi e, and this is minus a to a, and this is p s. So, p s is defined as p 0 into a minus s by a into x minus s into d s okay, and the q x is equal to 0, that we know. So, this will be one equation, and again here this is q s is equal to 0 here, and here this del du del u by del u at z is equal to 0 at del x, that can be written as, this is minus. So, it is minus here. So, it will be 2 into 1 minus sigma square by pi into e into, this is pi into 1 minus 2 sigma by 2 into 1 minus sigma into p x. So, p x is defined as p 0 a, and it is a minus, this is x like this. So, over here this 1 minus x and 1 minus x gets cancelled, not cancelled means it will be 1 plus, sorry, 1 minus 1 plus sigma, not sigma minus x, 1 minus sigma, and this is pi gets cancelled, and this is a is not fine, no, a is fine, sorry about that, a is fine over here. So, it is 2 and 2 gets cancelled over here. So, we can write this del v by del x and del u by del x something like this okay. So, now over here this v needs to be found out and u needs to be found out. Now, in order to find out v, we have to first do this particular integration. So, this integration we can write it like this. So, over here this a minus mod of s can be written as here from between two different limits, minus a to 0 and 0 to a, and here a, this mod s becomes minus s, so it is a plus s here, and it is a minus s over here. So, here now we need to integrate it. So, here this term a plus s can be written as a plus x minus s, and here a minus s will be written as a minus s plus x minus s. In essence, we have added and subtracted one x term over here in both the cases, over here and over here. So, notice that if we can integrate this part. So, it is a plus, it is with respect to s. So, it is a constant over here. So, it is a plus x and this is 1 by x minus s. So, it is ds over, so minus should come here. So, minus a plus a line x minus s and this is minus 1 here. So, therefore, minus s here and limit is between minus a to 0 and here it is a minus x by x minus s. So, a minus s it is constant and here it is ln x minus s and this is plus here. So, it is plus here like that. And if we further write del v by del 0, therefore, after doing this integration and putting these limits 0 to a, already I have put it actually. So, it will be something like this, this will come out to be like this and this quantity can be further written in somewhat more organized manner and for that I will like to write it as x plus ln of x plus a by x and for that we have to add here x plus 1 a term and minus n term. So, this particular term can be written here like this, okay. And once we do that and we bring this 2 here, so we can get something like this. So, it is just little algebraic manipulation and now we can obtain that v at z is equal to 0, okay, as minus this is 1 minus sigma square, this is p 0 by pi e a and it is we need to integrate it. So, it will be a plus x and ln of this is ln of x plus a by x whole square, a plus a whole square and this is d of x, okay, plus this is x minus a ln of x minus a whole square by x whole square like this and here again let us write it dx like that. So, this is the integration that needs to be found out and we can, this is not very difficult, we can use this result x of ln x, okay, dx, that will be this result x square by 2 ln of x minus x square by 4. This result we can actually use and we can work it out. So, I will stop today and I will continue in the next class and I will give the this final form of this solution of u and v and then we will see that what exactly, how does those profiles should look like or what kind of indenter should give rise to this kind of stress distribution, that is linear stress distribution. Thank you for your kind attention.